Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 9, 2025, which was just 2 days ago. The striking result is that longer chain of thought traces do not reliably signal harder problems, with apparent correlations showing up only when test mazes resemble the training distribution. The paper is titled Performative Thinking, the Brittle Correlation Between CoT Length and Problem Complexity. And the implications for model training are quite significant. In controlled maze tasks, the model hit about 80% accuracy on held-out Wilson mazes, but solved only 5 out of 100 trivial free space cases, often rambling to the 32,000 token limit without a solution. On X, a commentator says treating intermediate tokens as thinking spawned a cottage industry, then asks whether chain of thought length reflects problem hardness or is performative. Engagement looks moderate with about 100 likes. Alright. The previous figure highlighted weak alignment between token counts and actual effort. Figure 1 shows scatter plots that compare model trace length with the A-star trace length, using the dashed line to mark perfect agreement. Panel A shows free space cases where many points stack near the top because the model ran to the 32,000 token limit without producing solutions. Panel B spans varied maze generators and shows broad dispersion, which signals that longer traces do not reliably track problem complexity. So, the previous figure emphasized widespread mismatch between token counts and actual effort. Figure 2 presents side-by-side scatter plots that relate model trace length to A-star trace length with a dashed trend line for reference. Panel A, using Wilson mazes, shows a mild upward slope with clusters near a few thousand tokens, which hints at limited alignment. Panel B, using search-former mazes, displays heavy vertical spread and many points pressed against the 32,000 limit, so longer traces mostly fail to reflect problem complexity. Alright, the previous figure contrasted Wilson and search-former results. Figure 3 shows the free space setup, which is a 30 by 30 grid with open interior and only a solid border. The green S marks the start and the red G marks the goal, and both positions are random. This setup matters, because the shortest path is a straight line with no obstacles, so any long reasoning trace indicates unnecessary token generation rather than real difficulty. Okay, 2 takeaways stand out. Longer chain of thought does not reliably track problem difficulty, and any apparent alignment mostly reflects staying close to the training distribution. The broader implication is clear. Token length is a poor proxy for adaptive computation, so evaluations and training should use verifiable signals of effort. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.